definitely, you're setting an initial value to use as this ACC variable in each iteration. All right. Definitely need to move on though. So hopefully that's helpful. But we're going to talk about objects. So what are objects, and what do we use them for? Talk a little about the this keyword, and also factory functions, which we use to generate objects in a programmatic way. So the first thing to think about whenever you're sort of constructing an object is really an object is our human abstracted way from how computers actually process data, and turning it into something that we're more easily able to process. And the funny thing is that everything in our world is actually an object right in front of us, and all objects have attributes. And this is definitely like an exercise you get very used to in programming, where you start dissecting everything around you into just a series of attributes, right? I have a pen, so it's like pen, like dot length would be like something in inches, color, red, ink capacity, some amount, current ink capacity, it's like at 50%. Everything you kind of have around you, you can describe in essentially key value pairings. And that's what we start to do when we're both dealing with data that really represents actual sort of, more sort of real life object data, as well as data that is more in line with, non-physical things. For instance, when you load Twitter on your web browser, what's actually happening. So let's say just the component on the web page where your tweets appear or your feed appears. So it's everybody's tweets that you follow. Behind the scenes, those are probably just objects being generated, JavaScript objects. So some data is being read from a database, and then you have an array of tweet objects. And each tweet will have a property like, author, time posted, content. It will also have maybe associated data like the likes and the comments or retweets, etc. Right? And each one of those is an object with information around what's, like what the actual essence of that object is. And that's really all that's happening. So all this work you're doing with arrays and objects, those are the most common structures being used to render anything you see in any software today. It's really just collections of objects that then get converted into something visual for you to see, right? So at a the CS computer science level, right? So an object as a data type in this case is an unordered list of key value pairs. Very important distinction between an array, which is an ordered list of values, right? Objects, you can add new key value pairings into an object, but that really never guarantees what order you would receive them in when you try to iterate and just kind of print out every key and print out every value. So never rely on the order. You can sort it yourself manually. You can say, extract every key, then sort it alphabetically. Fine. But you have to do that sort. If you don't, there is no guarantee that a given key is going to come out in an order you want it to. And generally, we don't use objects to have ordering. We use objects to store all types of data where we don't really care about that order. Objects can contain all other types of data. So an object can contain an object, right? So you start getting like a tree-like structure of objects within objects that have other keys and values that lead elsewhere. Objects are mutable, just like arrays. You can change an object, the object in place. You can add keys to it, remove keys, add values, change values. And then there's just some terminology to like start getting used to, right? A property is basically every key value in the list. So a key value is essentially the entity of a key value is often called an attribute. A method is a key value where the value is a function. So there's nothing special about it. We just call them methods. So when you put a function inside of an object and you use that function, we call them methods. And you guys have already been doing that. The dot reduce method is really just a function. Someone wrote function reduce somewhere and then added this function onto every array you ever create. And to really blow your mind, everything's an object, with the exception of like primitive data, like strings, numbers, but arrays are actually objects. Functions are actually objects. They all just have special behavior around them. If you don't believe me, check out this like add all numbers function. Well, just like an object, I can add, a property to it. Foo equals bar, and that will work. And I can console log add all nums.foo. So there I have, a function, but I'm actually also accessing a property on it. Okay? But I can also add all nums and actually invoke it. That's unique to a function object. A regular object you can't invoke with parens. All right, I think I saw a beep. Did someone Oh, okay, yeah. Okay. So, creating an object just like creating an array using the object literal syntax. Pretty straightforward. Now, the only note here, just a little confusion that might have come up, but right, we talked about code blocks, right? That anything inside of a curly brace code block is its own scope, etc. So, for whatever reason, in many programming languages, the curly braces have two entirely different meanings. Curly braces in this case do not in any way start a code block, start a block of statements that get executed. When used in this syntax, the curly braces are simply creating an object. So that's just what it is. If there was another symbol on the keyboard that was easily available, that might have been what would be used for an object. But because there's very specific syntax behind, when we actually are using an assignment of the equals sign, then when we open a curly braces, it's saying we're actually about to generate something, and in this case, an object. If there was no assignment, then you start getting into that area where the syntax reader will think a curly brace is about to open a block of code. All right, and then we've got our properties here, and as you can see, all sorts of data types, strings, numbers, booleans, and we have a function as another value here. And so here, this is a method, whereas these are just regular old attributes. And then to access the property of an object, so similar to an array, you call the name of the object, and then you can use square bracket notation like you would with an array. You can also use dot notation, but there are some very specific cases between those why you must or mustn't use one or the other. Let's just see if I thought there was an example here. Okay, so in this one, so we'll cover that first. So I'll just grab this code. So in case this hadn't you haven't already, when you've been playing with this, right? So we have our, let's go ahead and clean up this, go to singles there. Okay, so notice here, so the first console log here is just little dot notation, floor color. So we should expect red from that, and we get red. Then we're going to use bracket notation and send in the string floor color, and that also works. And that is because keys on objects are always strings. That is how JavaScript stores them in memory. A key is a string. So really, this is actually this is actually what's happened, right? They're all just strings inside your object, and they're being assigned to the keys. But JavaScript, just again, like many other little shorthands, you don't have to create a string if you don't need to. It just sort of does that implicitly for you. However, it doesn't implicitly do it for you if you're not obeying variable name restrictions. So a variable cannot have a space in it. My variable, right? That is illegal and that breaks, and that's syntax error. So you have to combine them up. So just like here, we don't have spaces in our keys, except in this one we do. So we do have to create, put the string syntax in there to make sure that the syntax doesn't break. But we are able to make a key name where we have a space in it. That's fine. Also, a variable can't start with a number. So 8, that is also illegal. And so same deal would occur there. We can't start a key with a variable, with a number, but we could if we made it a string. That's the only sort of little note there, is that where you can use these sort of quick key shorthand, but you have to obey the same syntax we obey with variable names. So now what about this? So here we're using bracket syntax and we're just calling floor color. So why won't that work? I guess I'll go over here. Why won't that work? Do backticks work to make a key? Yeah, backticks are just a way of making a string, and strings are keys are strings. So you use backticks. Just typically we don't use backticks unless we're interpolating variables into our string. Doesn't look like anyone's answered that though. So the reason we can't use this is because, inside this square brackets, we're actually evaluating code. So in this example, we're sending in the string of floor color. So that's fine because the key is actually a string floor color. That's actually a string right here. But in this case, floor color doesn't exist. Floor color is not defined. We're trying to evaluate code inside of here, and just like whenever just like if I console logged floor color, that also wouldn't work. There is no variable called floor color. So I'm basically trying to send in an undefined variable, and that's why that won't work. And I'll just get a reference error when I run that. Right? So so that's that sort of key thing to remember, that when you open these square brackets, for accessing an object properly, you're really evaluating a piece of code in here. So if I, said, I'm going to just like foo key equals floor color, right? So the floor, I've assigned the floor color string to this variable. I can send that variable in, and that evaluates to the string. And that's just like sending in the floor color string, which is perfectly legal. And we get the red back, right? So, and that's often why we use square bracket notation, is when we don't know the key name, during the actual, like the key name is going to be something dynamic. It's going to be something maybe sent to you as a parameter in a function, or it's going to be something you're looping through. So you're going to loop through 100 keys, and you need to, access each value in those keys, and so you don't manually know what that key name is. So we use the square brackets usually to handle dynamic data and dynamic key names. And that's it. And then this just shows you what I set up above. Doc name, it's fine, because we can use it, we can explicitly state the string. Couldn't do it with dot notation because it would just break syntactically. We just get a syntax error there. All right, so any questions on that? So object destructuring. So this follows that same pattern of yesterday with array destructuring. So it's, so in this example right here, we are receiving the yacht object that we've been playing with, right? This yacht object right here. And then what we want to do is, so if we weren't destructuring right here, so notice now that all of these floor color are now not defined. So I'm going to have to directly say, okay, that one's yacht.floor color, yacht.floor color, et cetera. And, not the worst thing in the world, added a little bit more characters to it. But when you're dealing entirely with just that single object in the function, and let's say there are like 10 properties on the function you want to use, and you're manipulating in your code, it's just extra verbosity that doesn't need to be there. Also, if you're going several layers deep, that can just make it even more, long and hard to read. So often we will extract from our object just the specific properties we need to use inside of that given function. And so the non-destructuring way to do that, the good old ES5 way, might have been floor color equals yacht.floor color, right? So just be that same, like because we're extracting out two things, we have to, manually write out all the lines of code for those two things. And if we had 10 properties we wanted to get, we'd have to be writing 10 lines of code doing all that same thing. Whereas this just lets us do it all in one neat line there. So that's object destructuring. Even more, even crazier is that you could do that destructuring right here inside of the function definition. So this parameter of yacht, we can actually destructure it right there in place. And now, so essentially we received a single object as our first parameter, just as before, but we destructure that object in place so that we now have these two local variables available to us in our function. Now, and this is often why you'll be using a lot of functions where you'll notice that you might do something like, this library you've taken, and then your foo method, and then you'll often maybe send in like a string that like is sort of some kind of command, like, or some like action you want to do, like delete user. And then you'll send in what we often call an options object. So you might send in, delete user force true, like shrink or condense database. I don't know, whatever you want to say, like database afterwards true. Like it's just a place where we might have all these different sort of other conditions we want to send in. So the foo method here is, first it's taking in a string, and then it's taking in an options, like an object. And we can use that to say, oh, if options.force exists, like, force the delete or force the function to occur no matter what, something like that, right? So we often use this pattern of receiving an object to allow us to receive sort of multiple types of things that we don't know for sure if they're gonna put that in as a parameter or not. And so that's that same place where we could destructure this and say, okay, all we care about is if they send in the force in this particular case. And so then we can say if force, do something, and then continue on. So that's destructuring and reasons we might use it. All right. Bing in if there's questions. The for in loop. So this is how we can iterate through keys in an object if we want to. Again, you don't generally want to like have an object and then just use it to like grab absolutely everything in that, every key on that object and do something with that. If you're using the object data type to just manage flat data, like that tweet data example where it doesn't have methods on it or anything like that. It's just got, keys and string values in it, or strings and numbers. maybe you would go through it all, but usually you know what you want to access in your object, and you're not sort of just like iterating through absolutely everything in it. But the in operator here, you can use that to just go through every key in an object. And this is basically us just assigning a local variable. We call it key, but we could call it absolutely anything we want. Let arbitrary. So it doesn't matter, right? And that's still just going to be the keys in that object you're going through. Setting values. So you've already seen us do this. This is just that you can set property values just like you can set, assign values to variables. You just access the given property and then use the assignment operator, the equals, and set it. All object properties by default are overwritable. So think of them as a variable declared with let, right? Just like you can say let floor color equals red, and then later floor color equals blue. You can also do little yacht dot floor color equals red and little yacht dot floor color equals blue. There's to make a property on an object more like a const, where it cannot be reassigned something, you've actually got to dig into sort of object configuration, which we actually don't even cover for any part of this course, but it is available. The in operator, so that's just checking for the existence of a key in an object. And so another nuance there to note is that remember that there is a difference between the existence of a key in an object and the key being there, but the value being undefined or falsy in some way. So, in this example, so here we're checking for the existence of floor color on that, little yacht object we had. So if little yacht dot floor color, often you might see something written like where you'd say if little yacht dot floor color, and you just do it as that shorthand truthy value, right? So if little yacht dot floor color, resolves to something true, then do something. Well, that's not checking if floor color as a key exists. That's just checking if the value has anything in it. And that distinction is important because usually we'll check for the existence of a key in an object to make sure we've got the object we were expecting. So if the little yacht object always has a floor color, but it may be undefined, or it may be set to null, or it may be set to an empty string, which is also considered a falsy value. So that still means this little yacht object is legitimately the little yacht object, but it has an undefined value in it. So this is still going to come back as false. So we can't use this statement to determine is little yacht what we expect it to be. So yeah, existence of a key is not the same as the key's value being falsy or undefined. All right, so now we come back to the good old that spread operator. We used that with our arrays, right, to essentially decompile an array out into a list of things. We can use it to say, with our functions, like just receive every argument inside of our function as a list of items. So we can use this to help us merge objects together. So I'll just grab this. And this is a very common thing you will be doing. You will have objects, and you will often need to kind of combine them up into some new object that you're going to do something with. So here, what we're doing, we just have we have little yacht, we have little yacht 2, right? And here we're creating a new object. So we just got we're declaring a new variable and we're assigning it to a new object, right? That's an object literal being created right there. And then we're using that REST operator on the two objects that already exist to basically create a list of attributes. So it's going to go through each attribute and value and assign those attributes and values to this new object. If, just like with arrays, if we were to do that, that would not have a desired result. Actually, that would be a syntax error because, it would basically just assign little yacht to the little yacht object. So all you would have inside your object are two more objects inside of them. You will not have a single object of a long list of attributes and values, right? So if I console log new yacht here, I just have a single object of a bunch of values. We've combined, so now you see christened true is actually inside, oh, I guess that's, yeah. There's no new, yeah, roof color is a new key here, right? There's no roof color in little yacht 1, but we now have roof color inside our object, plus we've overwritten christened true. So now we've changed christened to true because it was false. And that's because the order does matter here. We're creating an object and everything in this first section will first execute, and then everything from the second object will execute over the first. And you can do this ad infinity. It will continue to overwrite towards the left. It's a useful way to merge objects. We can also use the special assign method that is set on the global object. So here we show that, so object.assign, its very first argument is the object we want to target. So that object itself will be mutated by whatever arguments follow it. So in this case, what would happen is we have our yacht 1, and then it will, just like we saw before, yacht 2 will be overwritten onto yacht 1. So any duplicate keys or new keys will be added. The duplicate keys will overwrite. So this new object would actually be floor color of blue. Now note, this actually won't do anything because object assign returns a new object, and we are not capturing the return value. So it will do the work, and then it will get lost forever. We would need to do like const yacht 3 equals object.assign to capture back the object that this assign method returns to us. Just like you capture, the new array that gets returned from a dot map on an array, right? But it's very useful for copying objects too. So in this case, the very first argument we send in, that's the big change here, is we send in an empty object. So to show this example here, I guess the names are wrong in that example. But so in this case, yacht 3 is now a brand new object. And yacht 1 and yacht 2 are not affected in any way. They are just, so basically, let's say on yacht 3, I change the floor color. Well, first we'll check yacht 3 floor color. So that should be what? So before we do anything, yacht 3, we're creating a new object. We're then merging 1, merging 2. So what will floor color be immediately on floor color? Everyone write it, blue, exactly. Then I'm going to change yacht 3 floor color to turquoise. Spell it, I think I can. And now, if I console log yacht 3 floor color, that, should be turquoise. And if I console log yacht 2 floor color, what will it be? So in this case, because we're making a copy, yep, blue, exactly, it's still blue. Okay, so we'll just run that to see it. And yeah, we got blue, turquoise, blue. Now, if I don't send in this first argument to object assign, so now yacht1 is the target. So actually that probably would have been the better thing to check, but we'll put it in here. Yacht1 is the target, which means that object assign will still return an object to you. It will still return an object. So yacht3 will still get assigned, but actually all that's happening is yacht3 as a variable is getting assigned to yacht1, the variable. And when you assign a variable to an object, you're just assigning a reference to it. You're not making a copy of it in any way. So now both yacht1 and yacht3 are pointing to the exact same place. So in this case, so let's do, so yacht3 floor color will still be blue. Yacht3 floor color, we're now going to change to turquoise. So we don't really need this. We know the yacht3 floor color has changed. But the question is, what happened to the yacht1 floor color? So I haven't changed yacht1.floor color anywhere, right? I haven't assigned it anywhere. But yes, following that logic, yacht1 floor color is going to be turquoise. We are now holding on to yacht1 in both yacht1 and yacht3, and we are affecting both of them. So have to be very careful with objects and arrays. They're both the same. When you receive them in a function, for instance, and want to start changing them, you're not dealing with that local scope protection that you thought you might have been. You have an object and you have a reference to that object, and anything you do to it will affect it. So you can have consequences outside of your function on this object. So if you don't want to mutate the object you received, you just want to do something else to it, you want to copy it and do other things to that and return information, you need to make sure you're making a copy of that object using something like object assign to make that copy. Just to show you that working there. So we can see yacht3 floor color is blue. We changed yacht3 to turquoise, and that has made yacht1's floor color turquoise. All right. This is just reminding you about const. Remember that const doesn't allow you to reassign. So if I say pet equals an object, I cannot do pet equals something else anymore. I can't make pet equal a new object or pet equal to a string. But just because it's a const doesn't mean I can't change the object in place. I can't mutate the object. So I can do pet.type equals dog, and it will change the pet object's attribute. So that's just there showing you what I said, that if I assign const pet equals object, I can't then assign pet to a new object with a different name, or just assign it to a different variable entirely. All right, property value shorthand, another good old ES6y thing. But so this is just showing you how it's very, very common that you will receive, like in this case, what we're doing is this is a factory function, which we're going to cover even in more detail in the slides ahead. But we have a function that accepts just a name, just a good old, like a string. And then we want to return a cat object out of that function. So first we get a color and just assume we have some random function that exists to return a random color to us. And the same thing with a breed. And so then we return an object where we're going to return an object with eyes set to 2, legs set to 4. And then we're also going to have a name set to the name that was passed in. And then we want color set to color that we just created as a variable, and breed set to breed. So, the normal way of writing that would be, right? Because we're setting eyes and legs to some static, static data that we have in mind from our function, but then we're setting the other ones to some dynamic information we received. We received name as an argument, and we actually generated color and breed inside of our function. So that would be the normal looking way to write it. But JavaScript shorthand allows us to just say, as long as the local variable has the exact same name as the property, you don't need to duplicate your writing there. So you may see this a lot in new code. The objects are, you can create a new object where you don't need to provide that key value colon break, as long as, but the only way this would ever work is as long as you have that local variable assigned. I believe that's true. It won't just make name equal undefined. If there was no, so if I just made up a new thing, foobar right here, that would actually, yeah, and you can see it's giving me an error. Foobar is not defined. So I'm pretty sure that would error out. At the very least, what it would end up doing is foobar undefined, but I actually think it's more likely to cause a reference error because it's going to try to assign foobar, the property, to, you know, an undefined variable, and that would be a reference error. That's object shorthand or property value shorthand. So showing the example of what you might get back from that function. All right, so now we're going to deal with this. We're only going to touch on the surface of this today. There's a lot of reading you can do about it. If you, I highly recommend, there's a Udemy course actually called JavaScript, The Weird Parts. Probably one of the best Udemy courses I've ever seen. And it's just really well explained. All of the detailed nuances of the JavaScript language, really breaks it down into what's happening. Highly recommend it. You can usually get it on sale for $10, $5 on when they have their sales, which they have almost every month. So definitely one to watch out for, understanding the weird parts. But he does a really good explanation of how this changes in a lot of ways. But you know, the briefly to cover, so this is a reserved keyword that is a variable that gets assigned to a value at the very moment the function is invoked, not when you're defining the function, right? Not when we're writing a function declaration and putting our information in. So essentially think of it as every single function that exists, the very first thing that's happening is let this equal to something going on behind the scenes in JavaScript, right? It is creating the variable of this, and it is assigning it to something. So what is it assigning it to? So it is specifically going to do, it's going to look for what was the object to the left of the dot when the function was called, right? So if this create cat function was actually a method on an object, right? So if I'm going to have like, you know, let's have we're going to have a cat god object, and that has the create cat function on it, right? And so here I'm just putting the create cat property, and I'm assigning it to this locally defined variable create cat, which actually in itself could use our property shorthand, but I'll just do that just to make it super clear. And now catgod.createCat, you know, we can now call that, right? So, so in this case, if I console log.this, this is going to be assigned to the catgod object. So this allows us to do what we call self-referencing. But, you know, functions get passed around a lot, right? Like this create cat, what if there's a, I don't know, a competing catgod, and then we'll have the same deal. That's going to point, and that could even point to our original catgod. It's a very weird example I've come up with here. So even though we're calling the function that exists on the first catgod object, this is always going to get assigned to whatever called the function, right? So when we invoke the function this time, this will get reassigned to competing catgod. So we'll be referencing this object this time instead of this object. So I think I actually just did in real time. Yeah. So this is the same example being shown here, essentially. So we have our little yacht. We call dot play horn, and that will execute this function where it console logs this dot horn sound. And this is going to get assigned to the little yacht object. So it's going to console log out Ride of the Valkyries. Whereas bigger yacht right here is, notice that play horn is referring to the function actually sitting over here. So you would think if I call bigger yacht dot play horn, it's gonna call this, you know, the function sits over here. So why isn't it referencing the little yacht? So this does not, just because the function is sitting on little yacht, and you know we have the this keyword, this does not equal to little yacht. It gets dynamically assigned at the time of execution. It looks like we had a question. Could you repeat? Yes. So I'm so that was me repeating it. So yeah. So just showing it here. And actually, the only other thing I want to kind of note here, right? So yes, we have. So I'm going to pull this function out, actually, just kind of like how we had with the cats. Here's my function on its own, and to notice that this function on its own, we'll call it play horn. So this function on its own is a legal function, and it's saying console log dot this dot horn sound. But there is no this at all, right? This is just a function sitting alone in the global space. So, but then when we give the play horn function to both, you know, and we'll keep that as little yacht dot play horn, right? So little yacht is actually assigned to a function sitting in global namespace, and meanwhile bigger yacht is assigning it to the function sitting here, which is really just a reference to the function sitting here. So all of this works because this, it doesn't matter that this function is just a global function with no object attached to it. All that matters is this function is being invoked off of this object. So this gets assigned to whatever the object was at the time that it was invoked. So we see the two things here. So here's a bit of a brain teaser. What will happen if I just call play horn? Play horn is just a function on its own, living on no object, and I am not calling it with an object reference before it. Anyone want to hazard a guess? Undefined. I believe that's correct. So the question is, why is it undefined? Just come back undefined. And so the reason is that essentially this always gets assigned to something. So if this doesn't have an obvious assignment of the object that was calling the function, it gets assigned to the global object, which depends on your execution context. In Node, the global object, I think, is just the word global. In your web browser, it's window. So I can actually show you, if I just open up my web browser console here, make it big. So let's throw in this play horn function, right? So now I have play horn, I'm going to invoke it, and it does come back undefined, and that's because window.horn sound is also undefined. But so the window object right here, you can see is this very large object with tons and tons of properties on it. So if I actually assign window.horn sound, you can see I've done this before, to trumpets. And now I haven't done anything to the play horn function. I'm just going to go ahead and execute it again. It returns trumpets because this just got assigned to the global object because it couldn't find an object otherwise that existed, and it made it all the way up to the global window object, and it found the trumpets property. All right. There are some who believe that in JavaScript, like there are certain purists, what's his name? Eric Oh, it's escaping me for now. He's a very popular blogger and JavaScript expert, writes a lot of content around programming, and he's a real purist. He likes JavaScript purely as what we call a functional programming language rather than an object-oriented one. Whereas JavaScript itself is actually a hybrid; it can be either, and or you can use either programming design pattern. And so he doesn't like this because it can be quite a confusing object. It can change contexts in unusual ways, and so he suggests avoiding it altogether and writing in a more functional approach. Much larger topic, much sort of bigger sort of meta programming concepts there. So we don't really dig into that yet. It's not necessary for the type of applications we're building initially. So just something to note. Okay, let's just cover. Do we do that, or should we do that in the afternoon? You shouldn't actually hit these drills yet, so maybe we will cover factory functions at the end. I want to let you guys get into the drills. These workshops run a little too long. So yeah, let's do that. You don't know JS. Yes, I think that's the guy. Hey, Eric with a C. It's bothering me. Oh, that's Kyle Simpson. He's actually another. He's actually similar. He has a similar beliefs around being very sort of functional programming. Eric Elliott. There you go. That's who it is. Oh, I guess he did author You Don't Know Jet. That's weird. Okay. I'm confused, but either way. Okay, so yeah, I think that's it for today. Thank you. I think, yeah, let's leave it there. So any questions about what we covered in the workshop? So you're going to be doing a bunch of drills. I think we have you redo the drills you might have already, well, you will have already done, but it might have been several weeks ago. Definitely want you to redo those from scratch. Don't refer to your older code. Make sure you understand what's going on in the drill so you can actually rewrite it. You should always be able to rewrite your code. And then we move on to new drills.